All right. Hi, everyone. My name is Matt Layher. I'm a software engineer at DigitalOcean, and today I'm going to be talking to you about Ethernet and Go. So let's start this off with a problem statement. Go's package net only provides IP, TCP, and UDP connectivity. But what if these protocols are too high level for our use case? What if we'd like to implement something on top of Ethernet, like ARP? Or what if I need full control over my application's traffic? One possible solution to this problem is to send and receive Ethernet frames directly in Go. And during this talk, I'm going to demonstrate two packages that I've written that allow you to do exactly this. So let's start off with an introduction to Ethernet frames. Ethernet frames are the fundamental unit of Layer 2 data transmission. As you can see in the diagram, a frame has several fields, and each one has a unique purpose. First of all, we have the destination and source MAC address. And these allow the frame to indicate where the traffic is going and where it came from. Next, we have an ether type value, and this indicates what type of traffic is encapsulated within this frame. Next, we have an arbitrary payload, and this could be the header for a higher level protocol, or really any arbitrary bytes. It doesn't really matter. Finally, we have a CRC checksum, and this is used so that machines on the receiving side of the frames can verify that the frame was not damaged or corrupted in transit. So let's suppose we want to create a broadcast message and send it using Go. So we're going to create an Ethernet frame, the Ethernet.frame type in my package. We want to broadcast the frame to all machines on our network segment using the special broadcast address available here as a constant. We'd like to identify our machine as the sender of the frames so that the other machines know where to reply. Next, we're going to identify our frame with an unused ether type. In this case, I just picked an arbitrary value. There's a full list of registered values if you'd like to avoid conflicts. Finally, we're going to encapsulate a simple message within our frame, just the bytes, hello world. Now that we have our frame crafted, we can marshal it to binary, and this will create the diagram I showed you earlier, that same binary form that's compatible with the wire format. Now that we've got the frame in binary form, we can send it over some network interface. It could be a physical interface, virtual interface, a tap, or what have you, really just about anything. In some circumstances, it can be useful to apply the frame check sequence, but normally the operating system will do this for you. If you find yourself in need of this functionality, you can just call the Marshal FCS method instead of Marshal binary. So while we're here, let's talk about VLAN tags. And these are a really clever extension of the Ethernet frame that enable you to split a single physical network into many logical ones. For the purposes of this talk, we're going to focus on the VID or VLAN ID field. And this ID enables us to, like I said, partition the network into many logical segments. So let's look at our previous example, but now we only want machines that reside on VLAN 10 to receive our message. So we're going to use pretty much the exact same fields we had before, but you'll notice there's now a VLAN with the Ethernet.VLAN type and an ID of 10. So now that we have our frame created, let's say we want to send over the network. In this case, we're going to use raw or packet sockets. The naming and terminology depends a little bit on your operating system, but in my case, I've just called the package raw for simplicity. So these enable you to directly transmit and send and receive Ethernet frames using your network interfaces. So in this case, we're going to select the ETH0 interface on a Linux machine. We're going to open a raw socket listener and specify the ether type of the traffic we want to send and receive. And this gives the operating system a hint that we would only like to be dealing with this kind of traffic. So we're going to craft the same frame we did in our previous example, but we're going to get it directly in its binary form, just to save a little bit of space here. Now that we have the frame ready, we want to broadcast it to all machines on our network segment. And you can use that with the write-to method. It's important to note that the raw.packetcon type actually implements net.packetcon, the standard interface in the net package. Once the message is sent over the network, we can listen for incoming messages to our interface's MTU and size. Once a message is received, we can unmarshal the raw bytes into an Ethernet frame, and then manipulate it in Go however we'd like. So in the future, I would love for some version of these packages to end up in Exnet. There was at one point an issue open to do just that, so here's hoping. But the problem is we need to be able to hook into the runtime network polar to do I/O efficiently and also to set timeouts. For the time being, I've implemented timeouts using a kind of hacky context mechanism, and I'm not super proud of it, but it does work. So maybe this is something that could be resolved for Go 110, and this is something I'm going to try to work on. I hope you've enjoyed this talk. If you're interested, my Go packages for manipulating Ethernet frames and raw sockets are available here, MD-Layer Ethernet and MD-Layer Raw. And if you enjoyed this talk but would like a more in-depth look at these topics, you can check out my blog on Medium, specifically Network Protocol Breakdown, Ethernet, and Go. Thank you very much for your time, and I hope you enjoyed the talk.